Since the marine industry is expanding in a world concerned with the emissions of greenhouse gases, environmental impact is under the scrutiny of the public eye. With regards to transport, research and development of materials and efficiencies endeavour to tackle these issues. Alternative renewable and sustainable fuel sources are becoming more utilised within the shipping industry. With this in mind, we were given a brief to design a radical new low-emission ferry, the Eco 400. This will replace the current outdated and environmentally unfriendly ferry. Our brief gave us guidelines to design a craft with the specifications of length 34 metres, beam 12 metres, draft 3 metres, and a capacity of 400 passengers.
We have produced this Gantt chart in order to be able to efficiently plan our time and to be able to keep a track on what has been done and what needs doing in order to meet our deadlines. We have allocated each person with a different colour on the Gantt chart so that each week we can meet and deduce what each person has researched or produced and fill in the chart accordingly. The main research areas that were addressed were materials, fuel sources, hull design and propulsion, and group members were each assigned an area to research.
This decision matrix concentrates on the power source we will be using in our Eco 400 passenger ferry. We scored each power source from 1 to 6, with the highest total score being the best. We instantly ruled out nuclear power due to the major safety hazards involved. It was a close call between hydrogen, solar and biogas, however our first choice was diesel, with petrol coming in a close second. Our scores were issued to each power source respective of research and our personal preference for our application. Modern diesel engines are much more efficient than those of past years. Emissions have been vigorously controlled worldwide, and as a result of this, new technology has been developed to reduce emissions and provide a more environmentally friendly diesel engine. Diesel engines have low maintenance requirements and are generally very reliable. They are safe and efficient, and these properties make it the ideal selection for our Eco 400 ferry. This decision matrix concentrates on the specific diesel engine selection. We selected 3 different diesel engines of around the same power output of 280 kilowatts. The first one was the John Deere 6081 AFM 75, a Volvo Penta D6370, and a Deutz BF6M 1015MC. As our ferry will be a catamaran, we will be doing a twin installation. The current operating ferries have a quad installation, enabling the vessel to operate in both directions without having to turn and dock. This method is efficient, however, purchase and maintenance costs are dramatically increased. Our ferry will be able to complete the round trip in the same amount of time as the current ferry, however it will use less fuel in the process, thus reducing emissions. Our ferry will use large electronically powered thrusters at the bow and the stern to enable it to rotate and dock with ease. We chose the John Deere as our preferred engine due to its low purchase cost, low fuel consumption and competitive dry weight. This engine has the following emissions requirements: EPA Marine Tier 2, EU emissions requirements, IWT 2004 26 EC, RCD 2003 44 EC, and is also MARPOL Annex 4 compliant. This decision matrix shows that our preferred battery choice for our power storage is the lithium-ion battery. Lithium-ion batteries are on average 4 times stronger and 4 times lighter than the similar lead-acid batteries. Their recharge time is also around 4 times faster, and lithium-ion batteries have a relatively low self-discharge. Lithium-ion batteries will remain 75% of energy after 1 year and are maintenance free. They are more expensive to purchase than the commonly used lead-acid batteries, however their lifespan can be up to 8 times longer and have a density of up to 900 kilojoules per kilogram.
We have selected the NeoWind 3D50 as our wind turbine. This particular turbine incorporates a self-orientated rotating propeller for optimum performance. It also has intelligent 3D blades that produce more electricity than conventional style blades. It has a diverse operating range from 2.5 to 35 metres per second, and with a wind speed of 14 metres per second, it will produce 2 kilowatts of power. The 3D50 emits only 25 decibels of noise pollution at 12 metres per second, ensuring a quiet trip for our passengers. With a total weight of only 185 kilograms, this was the perfect product for our eco-friendly passenger ferry.
For hull materials, we had 4 choices: wood, aluminium, steel and fiberglass. There were 5 factors that we took into account for each material. They were weight, cost, strength, maintenance required, and lifespan. Wood was the cheapest material, with reasonably good weight and strength, but would require a lot of maintenance to stop it from rotting, so he didn't choose this. Fiberglass was one of the more expensive materials around, but required little to no maintenance. However, if the gel coat cracked in any place, the fiberglass would absorb water and delaminate, so he didn't choose this material either. Steel was cheap, strong, and had a long lifespan, but was the heaviest material and would require a high quality paint to stop it from rusting. This meant it wouldn't be eco-friendly enough, as the boat would use more power to shift the weight, so steel was not chosen. Aluminium was the material we chose. It is a bit more expensive than steel, but it's much lighter and it won't rust. As long as electrolysis is kept at bay, aluminium will last forever. In the end, we chose to use recycled aluminium, as this would be cheaper and more eco-friendly.
In designing the Eco 400, we looked at a number of different hull shapes. There are many factors to take into consideration when choosing the hull design, such as the operating speeds of the vessel, stability, manoeuvrability, the deck space, carrying capacity, and the sea ride comfort. There are 5 main types of existing hull shape that are looked at, these being the planing hull, semi-displacement, full displacement, pontoon, and swath hull type. After analysing completing the matrix, despite the fact the swath hull type was found to have the lowest score, based on the fact that the intended location and use of the vessel does not require it to be extremely seaworthy, and the existing vessel travels at faster speeds, we felt that the speed factor was a more important consideration. The semi-displacement hull suits all the requirements, and the specification points out it's a good all-round hull, and it also displays favourable characteristics for the intended use.
The current Vancouver Sea Bus operates for a distance of 3.24 kilometers per day, which equates to 25 round trips and 0.13 kilometers per single trip. Our new Eco 400 will run the exact same time to ensure local businesses are not affected. The old ferry consumed 7.5 liters of diesel for every 1 kilometer it covered. This equals to an efficiency of 83 kilowatts an hour per kilometer. The new low drag hull design, encountering low emissions, eco-friendly diesel engines will dramatically reduce fuel consumption and therefore increase efficiency. The John Deere engines consume only 6.2 liters of diesel per hour when running at 1000 RPM. As our ferry is not real-life product, exact fuel efficiency cannot be precisely calculated. However, we calculate that the ferry will be approximately 50% more efficient. The following animation is a representation of our whole design for the Eco 400 ferry. The model's dimensions are 1 meter long, 15 centimeter wide per hull. The final model will be 1 meter long and 60 centimeters wide, with the deck resting on top, including the wind turbine. The inner structure of the hull consists of 30 sections. In the back, space is left for the engine and batteries. The model is made out of wood and is being fiberglassed to make it waterproof.
Being a coastal city separated by large waterways, Vancouver is the chosen location for our project. Because of its geographical features, Vancouver is separated by estuaries and rivers. To avoid congestion on the bridges for the daily commute, the popular alternative is to use the city's ferry services. The guidelines for this report state that the carrying capacity is for 400 passengers, making 25 round trips per day. Based on this, the assumed distance for each round trip is 3 kilometres, taking roughly 15 minutes each way with a 5-minute time in dock. This allows for the ferry to be in service 14 hours a day, travelling at a safe speed of 6 kilometres per hour. The target market for this ferry service is people commuting to work in the city. Since businesses located within the city depend on easy access for their employers and customers, potential investors in this project include businesses that operate in Vancouver City.
Efficient ship design is the future of shipping and water-based transport. From the decision matrices, it was clear to see what components were best suited to the job and make decisions regarding the ship's design. The decision was made to design a ferry with a single large alternative power source. The reasons for this was to dispense with the upkeep and expenses of having many smaller sources of alternative power. To have one large multi-directional wind turbine generating power when the ferry is off duty enables the craft to generate its own power without compromising the ferry service. Using hydraulics, the turbine is able to be erected in dock when required to generate electrical energy and stowed away when not in operation. The electrical power generated is stored and used to power the ferry's electrical systems, including lighting, auxiliary motors and bridge controls. The Eco 400 combines modern transport with efficient renewable energy systems.